This next problem has us finding the sine at pi over 12. Think about where pi over 12 would actually be. Pi over 6 is right here. So pi over 12 is going to be even smaller. So the y value, the sine value, is going to be very, very small. It's going to be very close to 0. Now, you can try to think of things that add or subtract to give you pi over 12 that are on the unit circle. But what I'm going to do is turn pi over 12 into degrees in order to make this a little easier on me. So pi over 12 radians, to turn into degrees, I'm going to multiply that times 180 over pi. So you get 180 divided by 12. So I'm really finding 15 degrees. That's what I'm finding. And I think it's easier to think about 15 degrees. So I either want to try to think of two things that add together to give me 15 degrees, or two things on the unit circle that will subtract to give me 15 degrees. So I'm going to use sine of 45 minus 30, because 45 minus 30 is 15. So this time I'm going to use the sine difference formula. So I'm going to use this one, the one where you're subtracting. So the one where we're subtracting says take sine of the first number times cosine of the second number and subtract cosine of the first number. And my u's and my v's represent first and second number times sine of the second number. So now I'm ready to simplify. Sine at 45 degrees is square root of 2 over 2, and I'm finding that on my unit circle. Cosine at 30 degrees is square root of 3 over 2. Minus cosine at 45 degrees, square root of 2 over 2, times sine at 30, which is 1/2. So when I multiply this out, I get square root of 6 over 4, subtract square root of 2 over 4. So my answer would just be the square root of 6 minus the square root of 2 all over 4. And that's going to be a very, very, very small number.